Hello and welcome to this video on quantitative sales forecasting. So in this video we're going to look at how we perform time series analysis to make a sales forecast, and we do that by calculating a 3-point moving average. Then we use a line of best fit to extrapolate to generate our forecast, and then finally we use the average variation approach to adjust our sales forecast to come up with a final forecasted figure. So let's go back in time a little bit and remind ourselves what sales forecasting is. Sales forecasting is a method of predicting future sales using statistical methods. Why might we do it? Well, we want to make sure we have enough sales in order to ensure good cash flow. We might need to make some operational decisions about how we run our business, organize our business in order to make sure we can meet our sales forecasts. We might need to make sure we have the right number of staff. We might also need to think about how we're going to ensure that we market properly in order to hit our sales forecast. So sales forecasting is a very useful thing for a business to do, and today we're going to look at how we go about statistically using a statistical process to make a forecast. And we do this by a process called time series analysis. And so we look at trying to predict the future sales by using past sales figures. So the first thing we have to do is collate or collect raw sales data over time. So let's imagine that this is sales figures that we have going back from 2003 up to 2015. And these are the actual sales figures. And what we're trying to do is we're going to try and create a forecast that we could use to generate 2016 and 2017's figures. And we do that by smoothing out the data using a process called moving average. So in this video, we're going to look at the 3-point moving average. So effectively, what we're trying to do is when we look at the sales data here in the actual sales data, we can see it jumps around quite a lot, 67, 70, 64, it's quite jumpy. So we want to try and smooth out some of these variations. We want a kind of a long-term trend. And so to do that, we look at taking an average. And we do that by taking something called the 3-point moving average. So first of all, I need 3 pieces of data. So my first 3 pieces of data here are the first 3 years, 2003, 2005. If I take an average of those, then the average there is 67. So my 3-point moving average here for the first 3 points would be 67. If I then change and go on a year, my next 3 data points here are 70 to 61. If I take an average of those, I get 65. So those are the data points for the next 3. So we call this a 3-point moving average. The average I'm getting on the right hand side here is being smoothed out as we move along down through the sales figures. So we add up the 3 periods of data and divide by 3, and then we repeat this process. The key point is to remember that the average always goes in the middle year. So 2004 there, the 3-point moving average for 2004 is 2003, 2004 and 2005. So I've calculated my moving averages, and I can see here I've moved it on to the next one. So I've got my 3-point moving average line continuing. So I've done the first 2 steps here. If I look, first of all, I've collected my raw sales data, and now I've smoothed it out by calculating these 3-point moving averages. Okay. The next step, step 3, is to plot the moving averages on a graph and draw a line of best fit to illustrate the trend. So here is my graph. The blue figures here indicate the actual sales figures that have occurred over time, and then the red line here, these are the points I've got for my 3-point moving average. So you can see it's already starting to smooth out some of the ups and downs that I experienced with my raw data. The next stage is to draw a line of best fit, and so a line of best fit really kind of summarizes the gradient of the red line there. So I should have equal amount of space below the dotted line as above when looking at my figures. So you just look at the points on your graph and you say, okay, that's the line that kind of goes through the middle, or best describes, best fits this. In reality, a lot of statistical programs like Excel, spreadsheet software for businesses will do this for them, but you just look at your graph and you put your line through. So we've done the first 3 steps now. We've looked at the data, smoothed it out, and now we've done a line of best fit. The next step is quite a fancy word here, extrapolation, to extrapolate to forecast the future sales. Really, that's quite straightforward. All we do is we just extend the line. We extend our line of best fit to the future, and now we can see that we can start to make a prediction for 2017. So if I go up on 2017 to my line of best fit, I can see that if I look at my extrapolated line and read off the axis here, that my expected sales forecast is looking like £71 million. So you might have thought that that's all the steps, but actually there is a last step here, and that final step is called adjusting for variation. So I've got my line of best fit here and I've extended it, but actually my line of best fit won't necessarily be completely accurate against my actual data. And there might be some variation that I've missed out. And so what I need to do is adjust for this variation. So here's a very good example on the right hand side. Here are my actual sales figures. Here's my 3-point moving average, my kind of smoothed out version. And I can see here there is a variation, there is a difference between the actual sales figure and the 3-point moving average. This gives me a variation. Now if I take the average of all those variances, then I would see that actually on average within a year, our moving average is 0.6 below the actual sales figures. So I find out the average here, I look at all the variations, I add them all up, so all the variations they added together are 6.67, divide by the number of variations that I have there, which is 11, my average variation is 0.61. So what that's telling me is my prediction is likely to be 0.61 lower than the actual. So I need to add this to my line of best fit to improve my forecast slightly. So my final prediction for 2017 would be 71 million from my line of best fit plus 0.61 based on my average variation. So if I include this now, my final prediction for 2017, my final forecast, I take my line of best fit, which I've extrapolated from my moving average, and then I add on, I adjust for the variation between my moving averages and what's actually happened in the past. And so my prediction for 2017 will be 71.61 million as a sales forecast. So there we have it. That's how we perform a sales forecast using time series analysis. So these are the steps that we need to go through. So this is quite important to make sure that we have these steps down in our notes. Remember, compared to last year, it's more about steps for process than remembering particular formula. So 1, collect the data. 2, we perform our 3-point moving average. 3, we plot the averages and draw a line of best fit. 4, we extrapolate to give our forecast. And 5, we look at the average variation and we adjust our forecasted figure by that amount. So in this video, we've looked at using time series analysis to calculate 3-point moving averages. We then extrapolate them and then looking at taking an average variation to adjust the sales forecast. That's it. Thank you very much for listening.